Hi everyone, welcome to the course of the welcome to the chapter atom. We are discussing this chapter. We have already gone through last two lectures. In first lecture, we discussed the Dalton hypothesis first, then we discussed the Rutherford planetary model for the atom, and after that we discussed the Bohr atomic model, which is very important, and in last class also. So, in this class we will extend the Bohr model, as I mentioned in previous class. At last, in this part we will discuss the Bohr atomic model. We will extend this model for hydrogen atom basically, and after that we will discuss the atomic spectra for hydrogen atom. That is very important. Why? Because as we discussed earlier, that atomic spectra, this was the experimental evidence, one of the most important experimental evidence which says that atom is discrete. That means atom is not the indivisible part of any matter, as mentioned by Dalton in his hypothesis that atom is the most indivisible part, the smallest element, smallest building block of any matter, as Dalton mentioned. But actually what happens when J.J. Thomson did his experiment, he discovered the existence of electron. So from that experiment it was evident that atom is not the indivisible part. We can go into the atom as well, and into the in the atom there is electron which is negatively charged. From there it is very trivial to say that as overall atom is a neutral species, that's why the overall matter is neutral, then there must be some positive counterpart of electron inside atom, which makes overall atom is a neutral species. So, and after that J.J. Thomson gives the palm pudding model, but that model was not that much efficient to actually the palm pudding model was there are some drawbacks, flaws in that model, and the model was not so much powerful to give the proper justification of experimental results, and at that time that's why the palm pudding model was not the accepted one. After palm pudding model, Rutherford gives his planetary model for atom. We have discussed the experimental setup, total experimental setup, experimental results, and from that experimental results Rutherford built up his model, and he, according to his model, inside atom most of the part is vacuum, there is nothing, but very small part inside the atom, in the center of atom there is very small part in which the most of the mass of the atom is centered. That part is called nucleus, and that part is basically positive charge particle. Around that positive charge particle, around that nucleus, electrons are revolving. Okay, that was the model of Rutherford. Also Rutherford gives the idea of proton. Okay, what was that idea? I am just recapitulating the whole stories before going to the next part. What was the idea of proton? That as there are, let's say, any atom, there are z number of electron is there. If z number of electron is there, then there must be z number of another element, another particle, which Rutherford mentioned as proton, which is positively charged particle, and the charge of proton or electron are same. That's why if there is a z number of electron, then there will be z number of proton, then overall charge will be neutral. And that z number of proton is actually coagulated at the center, we can say that is just in the nucleus, that is nucleus, the bunch of proton, that is called nucleus by Rutherford, and that bunch of proton which is nucleus, and that around the nucleus the electrons are rotating, and overall charge is neutral because the charge of the electron is Zd, because Z is the number of plus Zd, rather plus Z is the number of electron, and plus is the charge of proton. Okay, so there must be same number of electron and proton, that's why Z is called number of proton or number of electron, we can say that. But by definition Z is actually atomic number, which is the number of proton. Okay, but as we mentioned, for a neutral atom the number of electron and number of proton are same, that's why Z is the number of proton, number of electron, we can say, we can use it for both cases. Okay, that's the model of Rutherford. But in Rutherford model also, by Rutherford model there are some that's okay because that was able to give the justification of the experimental done by Rutherford. But there are two problems as we discussed. First one, that was the continuous energy spectrum, because according to Maxwell theory, what was the if there is an accelerated charge particle is rotating, that electron is rotating around the nucleus, so it's rotating, so it's an accelerated particle, we can think like that, it's actually accelerated charge particle. So from that accelerated charge particle there must be electromagnetic radiation should be emitted. So from electron there must be some emission of electromagnetic waves. If that is the case, then the spectrum, the atomic spectrum of the hydrogen atom, we can say that, because the atomic spectra of hydrogen atom was very important experiment at that time. That is the we can say this experimental evidence was the backbone of this discovery of this atomic structure, we can say. It's we'll discuss atomic spectra in details later. So now, but in atomic spectra we saw the discrete lines, it was not continuous. Okay, that was the first problem that was not answered, that was not justified by the Rutherford planetary model. And another one, there was another drawback, that if electron is revolving, then and it is emitting the energy, then after some time it should be clashed into the nucleus. But that is also not the case. If that occurred, then our overall universe, overall system, any matter would not be stable. But that is not the case. But these two flaws were accounted by the Bohr. After that, if Bohr gives his model, Bohr's atomic model, what Bohr proposed, Bohr first extend the Rutherford model little bit. We discussed that, the mathematical part, that there must be, as electron is rotating around the nucleus, so there must be some centrifugal force and centripetal force, that force are balancing each other. In this case, the nucleus is attracting the electron due to the electrostatic force, and that is the z square by r square, that force, and that is outside force, that outside force is due to the angular velocity, which is mv square by r. This force actually balances each other, and that's why electron can rotate up in a fixed path. This was proposed, this was extended by the Bohr. But there was major two postulate given by the Bohr. First one is the we can say not major two, major three postulates, sorry, major three postulates were there. First one is the electron is rotating around nucleus in a specific, or in some specific orbit, in some specific orbit. That means electron can't rotate in any radius around the nucleus. There are some fixed or specified values of radius which are allowed, in which electron can rotate around the nucleus. This was called the stable or stationary orbits. These orbits are called, that radius are called. This was the first postulate of Bohr. And also Bohr said that when electron rotates, revolves around nucleus, in those orbits it does not emit any kind of energy from it. That's why it's also called the stationary orbit. Though it is against the Maxwell laws of electromagnetism, because electron is a charged species, though it's not emitting any kind of energy, any kind of electromagnetic waves from it. Okay, its energy is constant, it's constant of time, it will not reduce any kind of electromagnetic radiation from it when it is revolving in a stable orbit. This was the second hypothesis, second postulate. When any energy can be, then there one question may appear, that if that is the case, then all the time electron will revolve around the nucleus, no energy will be accepted, or no energy will be emitted from any atom, then there will be no atomic spectra. We should not have any kind of line in the atomic spectra. That is also not the case, because in atomic spectra we are getting some line, though that is not a continuous spectra, that is a discrete one, but still we are getting some wave, spectrum for getting lines for a particular wavelengths. That should not be occurred if the stationary orbit is correct. Bohr said that no, stationary orbit is correct, but there is not only one stationary orbit, there are more than one, 5, 6, 7, 8, in principle infinite number of principal orbit or stationary orbit or stable orbits are there. So electrons can rotate in those orbits. So and between these two orbits, electron can be excited or de-excited. Means, let's say if it was orbiting in one stationary orbit, and this is the another one stationary orbit, and electron was here first and it jumps to another stationary orbit, then it requires the extra amount of energy. That let us say it is E1, it is E2, then E2 minus E1 daily amount of energy is required for this excitation. So, when we in that case electron will absorb the energy. And again let us say for de-excitation case also, if it is goes down from E2 to E1, then also daily amount of energy will be released by the electron. So, in those cases from atom we can have some spectra, that may be emission spectra, absorption spectra. There are two kinds of spectrum, we will discuss later those details, but this is the case. This was the second postulate. And the third postulate was the, okay, that is correct, okay, that is we are accepting that there are some orbit, there are some specified values of specified radius that are allowed in which electrons can orbit the nucleus. But how we can determine those orbits, how we can determine those allowed radius? For that Bohr said that those radius which are R is radius here, which satisfies this equation mvr equal to nh by 2 pi or mvn rn equals to nh by 2 pi more generally. N is the suffix, the nth orbit, n means the nth orbit. For nth orbit in general this equation must be satisfied. Vn is the velocity of the electron in that orbit and r is the radius of the orbit. So, if this is followed, then that orbit will be allowed, then that orbit will be stationary orbit. Okay. For that orbit electron can rotate, in that orbit electron can rotate around the nucleus, that was the case. So, what was this was the most important postulate. From here we can get the idea of quantization, because here we can see that any radius is not allowed, n equals to 1, 2, 3, these radius are allowed. So, there are some specific value of radius in which electrons can orbit. So, if a specific orbits are allowed, that means specific energy electron can have, right. So, del E that must be specified, this del E must be as E1, E2 these are specified. We also evaluated the form of Rn, En, right, in last class. We will extend from there, but del E is specified, that is why del E is also take some restricted value, specific value, and as a consequences in atomic spectra we obtain some specific lines in some specific wavelengths, other portion is totally dark. That is the explanation. We can give this explanation from the atomic spectra. So, we will discuss the atomic spectra in details later, but first we will discuss, we will carry forward from the explicit form of Rn, En, and we will carry forward for the hydrogen atom, what will be the forms of those radius, energies, these things, right. So, we are going to start today. Hydrogen atom. So, in case of hydrogen atom there are Z equals to 1, not there is only one electron in the hydrogen atom and one proton, because Z is 1. So, this is the center nucleus, one proton is there and around one proton there is only one electron that is revolving around the nucleus. Okay. So, up to this part whatever we have studied, there are two particles in atom, one is electron, one is proton. Okay. So, you may heard about the neutron, but Rutherford, in Rutherford model there was no concept of neutron. After Rutherford I think Chadwick gives the, yes, Chadwick was a student of Marie Curie, he gives the idea of neutron. Okay, that is not included in this part, we will discuss that in next chapter, in the nuclei chapter. Okay, but up to this part when we are discussing the hydrogen atom, in hydrogen atom there is no nucleus as such. That is why in those atomic spectra of hydrogen atom there was no evident obtained which implies the existence of neutron. Okay, because in hydrogen atom there in nucleus there is only one proton, and but deuteron is very important, because due to neutron the binding energy will be provided. Okay, we will discuss that in the atomic nuclei part. Okay, so here there is only one proton. Okay, we have also said that for proton the symbol is the notation is here it is +1 and here it is 1. For proton there is mass, because according to Rutherford electron has negligible mass and most of the mass is centered in the nucleus, that means in proton. So, proton is much more heavier than nucleus and most of the mass almost 95 actually or more than that, most of the mass is actually coagulated in proton's mass. So, it is proton and for electron it is -1 0. Okay, this is the case. Okay. So, now we will discuss for hydrogen atom what will be the cases. This is the orbit, right? Let me use another color. This is orbit in which electron is rotating. Okay. So, what was the expressions we obtained in the last class for Rn, allowed radius in which electron can orbit the nucleus, that is epsilon naught n square h square divided by pi m z square. This was the form. Now, in this part we will discuss for only for the hydrogen atom. Okay. So, for hydrogen atom it will be z equals to 1. Okay. And what was the energy? Energy was minus z square E4 z square divided by, we have already derived these forms in last class, right. So, for hydrogen atom it will be En is equal to minus m. Okay, what is the m? M is actually mass of electron. This is the form. Okay, and this is the total energy. In nth orbit. So, we can see from here n is quantum number because it makes the quantization. Oh, we have discussed the quantization in dual nature of matter and radiation, that part. So, we are familiar with the quantization, these terms. Okay. So, n is the quantum number, it may vary from 1 to 3, but in principle it goes up to infinity. In principle there will be infinite number of orbits. Okay. So, in this part we have just introduced, we have started to discussing the hydrogen atom. We have evaluated the form of Rn and En for the hydrogen atom. In next part we will continue from here and we will see, we will derive the Rydberg constant, the expression, these things, the series, this part. We will try to cover this series to this class. If not possible, then in next class. Okay. So, let me stop here in this part, we will continue from here. Okay. Thank you.